Good day, everybody. We've been given this question. We expected to integrate this. It's integral 0 to pi e raised to the power of cos x times sin x divided by 1 positive cos squared x times e raised to the power of cos x positive e raised to the power of negative cos x. So what we will do is we will use this property, which is integral 0 to a f of x dx is going to be integral 0 to a f of a negative x times a dx. So if I were to take this property and apply, so therefore one can be rewritten as I is equal to integral 0 to pi e raised to the power of cos of pi negative x times sine of pi negative x divided by 1 positive cos squared of pi negative x times the e raised to the power of cos of pi negative x positive e raised to the power of negative cos of pi negative x times dx. Now cos of pi negative x is cos pi cos x positive sine pi sine x. So this goes off. Cos pi is negative 1, so you get negative cos x. Now sine of pi negative x is sine pi cos x negative sin x cos pi. So this goes off. Cos pi is negative 1, so you get a sin x there. And is there anything else? Okay, so we are set. So applying these to the integral, we get integral 0 to pi e raised to the power cos of pi negative x is negative cos x. Sine of pi negative x is sin x. This is going to give us cos squared x back. So it's going to be 1 positive cos squared x. Now this is going to give us e raised to the power of negative cos x. This is going to give us negative cos x, but there is already a negative, so it's going to be positive. So what do you see here? From 2 and 1, the denominators are one and the same. You see that denominator? So adding 1 with 2, you get 2 times I is equal to integral. So the numerator is going to be e raised to the power of cos x times sin x positive e raised to the power of negative cos x times sin x divided by 1 positive cos squared x times e raised to the power of negative cos x positive e raised to the power of cos x. Now I can take sin x out, right? So this is 2 times I. Of course the limits are 0 to pi. So integral 0 to pi, I take sin x out, I take sin x out, what do I get? I get e raised to the power of cos x positive e raised to the power of negative cos x times the dx divided by the denominator, which is 1 positive cos squared x multiplied with e raised to the power of cos x positive e raised to the power of negative cos x. Now e raised to the power of cos x positive e raised to the power of negative cos x, you see that goes off with the 1 on the numerator. So you have 2 times I is equal to integral 0 to pi sin x over 1 positive cos squared x times dx. So now we need to make the following substitution. So let me take cos x is equal to t. I differentiate cos x, I get negative sin x dx is equal to dt. This means sin x dx is equal to negative dt. Now when x is equal to 0, what happens to t? T is equal to 1. When x is equal to pi, what happens to t? T is equal to negative 1. So if I were to take this as 3, hence 3 becomes, so 2 times I is equal to, is going to be 1 to negative 1, and then you have sin x dx negative, that's dt, right, divided by 1 positive cos x is t squared. Now I flip the limits. That's going to be negative 1 to 1 dt over 1 positive t squared. I rewrite it as 2. I can rewrite it because t's power is even. So this is 2 times integral 0 to 1 dt of 1 positive t squared. Now what is this? This is nothing but tan inverse of t, 0 to 1. Okay. So if I substitute tan inverse of 1, what do I get? I get pi over 4, isn't it? Tan inverse of 0, we don't have to bother, that gets vanished. So this is what we get. On the left we have 2 times I. So 2 and 2 gets cancelled, giving us I is equal to pi over 4. That's the solution for this question. Please like, share and subscribe. Thank you.